Let's graph the following functions and see what they look like. We have x squared, x to the fourth, and x to the sixth. Notice they all look somewhat similar. They're getting a little bit skinnier. And if we zoom in to the origin, we can see a little bit of difference. It's getting a little bit flatter around the origin, but in general, they're opening up. So if we're looking at x squared, we're somewhat familiar with x squared looks like already. We have 0, 0, 1, 1, 2, 4, 3, 9, and so on. You can get a rough sketch of what that will look like. It's that familiar parabola. And then if we look at x to the fourth, it's going to go through negative 1, 1, 0, 0, 1, 1. And the graph gets a little bit skinnier, still going through 1, 1, but it gets flatter as we get close to the origin. And then x to the sixth, again, is very similar, a little bit skinnier, goes through 1, 1, gets a little bit flatter as we get close to the origin. And we have, again, very rough sketches of what those look like. The whole point of this is recognizing what's happening to the ends of these graphs. So notice that the power functions here all have even degrees. And with even degrees, the end behavior, in this case, they're all pointing up. Notice on the left side, the graphs point up, and on the right side, the graphs point up. This time we'll look at odd power functions. So we have x to the third, x to the fifth, and x to the seventh. So x cubed we're somewhat familiar with. We have negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. So we can get a rough sketch of x cubed. X to the fifth has a similar shape. It also goes through negative 1, negative 1, 0, 0, 1, 1. At negative 2, it's a little bit skinnier, so we'll start down here. We're just going to get an approximation. Around the origin, it gets a little bit flatter and continues up. Then x to the seventh, again, is very similar. It's going to go through negative 1, negative 1, 0, 0, 1, 1, but it has a skinnier shape. Again, closer to the origin, it gets a little bit flatter. And we have a basic shape of x to the seventh. Really, what we want to take away from this is recognize that these power functions have odd degrees, and look at the end behavior of what's happening. It's going down on the left and up on the right. So in summary, if n is even, the ends of the graph are doing the same thing. They're going in the same direction. Either they're both pointing up or they're both pointing down. When a sub n, the leading coefficient, is positive, the graph is going to be pointing up on the end behavior. If a sub n is negative, remember that's a reflection across the x-axis. So now those ends are both pointing down. There's going to be some wiggle room in the middle, potentially, that we'll look at later, but end behavior is determined by the degree and the leading coefficient. If n is odd, that is, if the degree is odd, then the end behavior is doing opposite things. One's pointing down and one's pointing up, or the other order, pointing up and down. And the difference is dependent on the leading coefficient. If a sub n is positive, think of this as increasing overall. Overall, the graph is increasing. Again, there's some wiggle room in the middle, which will be determined by other factors later. But in general, the graph is increasing. And if a sub n is negative, that is, if the leading coefficient is negative, the graph will be overall decreasing.